All right, hello. Welcome everyone. Go ahead, and I know it's crowded in here. Looks like we still got some seats kind of over back on this side. If you're still walking in looking for a seat, most of the empty ones look like they're kind of back over that way. We're gonna go ahead and get started. Welcome. My name is Doug Shook. I am the instructor for this class, but I'm not the only instructor for this class. This is a big class. You can see that there's a lot of students here, right? And this isn't even it. There's actually a whole other lecture session right after this one that's got another 100, 150 students in it. So we're looking at about 360 or so people in this class as of this moment, as of right before class started. Can't do it by myself, absolutely cannot. So we have a whole lot of help, including my co-instructor who's going to introduce herself to you in just a moment. And we also have a whole army of TAs who you're going to get to meet and know, and who are going to be helping you out over the course of the semester, including our two head TAs, Dorian and Abby, who I don't believe are here with us right now, but you'll get to meet them in the lab sections later on this Wednesday. So let me start off with a brief welcome message, just to make sure everybody knows why we're here and what we're here for. Yeah, this is an introductory computer science class, and I want to start by just assuring everyone that you are welcome here. This is an intro class, so that means that it assumes no prior knowledge of the topic. That means that if you have never written a line of code in your life, you've never looked at a line of code in your life, you're in the right spot. This is the place for you. I know that that's probably not true for all of you. Some of you maybe have taken some computer science either formally in high school or some other kind of coding program, or maybe informally, just as a hobby, working on your own time. You're welcome here too. I do want to point out though that for those of you who do have coding experience, right, remember this is an intro class. I am going to be starting from the very beginning. So, if you have had some coding experience before, this may not necessarily be the best fit for you. This may not necessarily be the best use of your time. You're honestly going to be better at making that decision than I am. I don't know your background. I don't know your coding skills. But if that's something you want to chat about, I'd be happy to talk to you about it sometime. I also want to let you know that for those of you who have taken the CSAP exam, if you got a 4 or higher on the AP exam, you are allowed to skip this class. So that is something I would strongly encourage you to consider if that applies to you. And there's also a placement exam. So if you haven't taken the AP exam, but you do feel like you have enough coding background to where this class is maybe not the best use of your time, going to cover stuff that you already know, there is a placement exam. A link to it is on the Computer Science Department website. So you can go take that exam today if you want to, and go through the topics that are on the exam, and they'll usually get back to you in the next week or two with the results and say, hey, yeah, you know this stuff, you can move on up to the next comp sci classes, or no, we think you should probably stay in the intro class and brush up on your skills. So I just want to make sure that everybody understands, right, what this class is for, what we're going to be talking about. We're starting with no knowledge expected. While I know that's not true for most of you, when I'm up here teaching, I'm going to be teaching to the people who have never coded before. Those are my primary audience, right? That's my primary audience, the people who I'm most concerned about in this class, people who have never seen a line of code before. Everybody else is welcome here, but my goal is to help somebody learn code who has never seen it before. So the other thing I want to mention is that all of you are welcome here in the sense that I fit a pretty standard comp sci profile, right? If you think about big names in tech, Bill Gates or Mark Zuckerberg, for example, they look like me. They are cisgender white guys, right? And so I think that should change. I'm consider that part of my job to some degree to encourage that change in the field of computer science. So it makes me really happy to see that there are people here from all backgrounds, right? I want to make sure that everybody feels welcome here, even though that I'm not going to stand up here and deny that computer science is a traditionally male-dominated field, right? I'm not going to deny that that's true, but I want every single person to feel welcome in this class, in this classroom, regardless of what your background is, regardless of what your gender is, regardless of anything. We are here to learn computer science, and anybody who wants to learn computer science at WashU is absolutely 100% welcome in this room. So I think that's a very, very important thing to say right off the bat. And now that we've gotten that out of the way, let me introduce myself a little bit more. My name is Professor Shook. I'm a WashU alum. I actually graduated here with a master's degree. Gosh, it's been a while now. 12 or so. It was about when I got my degree. I've been teaching CS here this is my 15th year teaching CS. I haven't been teaching this class that entire time, but I actually did start out as a TA for this class when I was a graduate student a long, long time ago. So I've been associated with this class for a very long time. But this isn't the only thing I do. Actually, this is, a pretty small role compared to my primary role outside of class, which is being a dad. And if you're around me long enough, you will definitely hear me talk about my kids, because I think about them probably more than anything else in this world. So you'll hear me mention my little kiddos a lot, and my beautiful wife as well. But I also have other hobbies outside of computing, although I am a big fan of video games. That's kind of what got me into computing in the first place. One of the first coding experiences that I ever remember was a game called Gorillas that was written in a language called BASIC, which people don't even really use anymore, but did exist back in the early 90s, and I loved it because you could actually tweak the code of the game and then see what effect it had on the game. That was sort of my first exposure to coding as a kid. It's still really what drives a lot of my coding, motivation these days. I'm really big into speed running, so I've actually held some world records in some old Nintendo games. I'm getting into jigsaw puzzles a lot lately. I like to speed run those as well, so I can do a 500 piece in about an hour, trying to get better at that. And I also love doing music. In a past life, I was probably a drummer or something along those lines instead, but in this life, I'm a computer science professor, so I still like drumming, still love music, so I'd be happy to talk to you about any or all of those things outside of class. But let me take a moment to invite my co-instructor up here to introduce herself as well.
Thank you. Thank you, Professor Shuk. Hi, everyone. I am the other instructor of this course. Very welcome and happy new semester to all of you. My name is Sarah, and my last name is Nurulahian, probably a mouthful last name. I completed my PhD at the University of Utah and the School of Computing. And in contrast to Professor Shuk and probably many of you, I'm not into games. I'm not also interested in computers for their own sake. I'm interested in how they make us capable of answering lots of very interesting and fascinating questions. And I do have a couple of questions that I wrote down here. I would like to just read them for you. And one is that, and these are not kind of recent questions by any means, but they're very important and very interesting, and I don't think, or probably we have been able to address them to some degree, definitely not to this large scale that we can address them today with the help of computers. So for example, how can large scale medical records and the imaging data that we have can help the doctors diagnose or detect some health issues like Alzheimer's and cancer diseases early on in the early stages? And these are very important questions. So another question is that we do have these wearable devices like smartwatches, right? How can we make them to track people's health more accurately and then let us know if some health problem is going to happen, God forbid, but like a heart attack may happen to someone. How can we prevent that in a timely manner? So another question would be, which is related to my research, which is in computing education, is how, now that we see lots of people interact with online resources and online platforms, how can we take this data and see how students use them and then try to design more effective devices for students to improve their learning and make the education more personalized for the students. So this leads to my research area, which, as I mentioned, I'm mostly doing computing education, whatever that helps us to have a better environment for computing students, to make them learn more effectively, to make them be more prepared for their future jobs and everything, which is computing education goes under the broader umbrella of human-computer interaction or human-centered computing, which deals with Well, we are making these technologies and tools for human to use, right? So we have to keep the human in the loop to make sure that the design of this technology is appropriate for human and will be effective for human. And by the end, I know that my last name is a pretty long one, so I would appreciate it if you can call me Dr. Nuri or Professor Nuri. Welcome again, and I'll go back to Professor Shuk. Thank you.
All right. Yeah, thank you very much. You're going to be seeing, so just to be clear, you're going to be seeing both of us here over the course of the semester. We're probably going to alternate in terms of who's going to be up front here lecturing on a given topic, and you're going to see both of us in the labs on Wednesday walking around, checking in on everybody, making sure everything goes okay. And we're also both available to meet outside of class in office hours to help out with things as well. So just trying to make sure you're aware of who the different people are that you can ask for help. Yeah, let's hop into kind of what today is all about. If this is your first class or one of your first classes, you're about to enjoy your very first syllabus day, although I imagine probably you've gone through a bunch of syllabi already this morning in some of your earlier classes. Let's talk about the structure of this course. So everything is broken down into modules, and if you actually log on to this class on Canvas, it's going to show you those modules right out of the gate. So most of those modules are going to take roughly a week to complete, which means that every time you come here on Monday, we're going to be introducing a new topic for that week. The idea is that you then will go into labs on Wednesday, and that is going to be what we call studio time, where you're expected to work together in small groups on a coding problem in class. And you actually, I think get a lot better hang of the material by working on it and talking with your peers than you would get by just listening to me, for example. We'll talk more about that a little bit later on. Each module has an assignment. Unlike past semesters, we're actually not going to be grading the assignments. So I know for a lot of you that probably means you're thinking about not doing them. I would encourage you to think very carefully about that. Because just because we're not grading the assignments doesn't mean they aren't important. I wouldn't be posting them if I didn't think they were important. We're trying to teach you a skill in this class, and the way to get better at skills is by practicing. So even though there's no credit waiting for you at the end of a homework assignment, that practice is going to be pretty vital for you to do well in this class. We're going to ask you to practice actually multiple times outside of class. As I'll explain a little bit. And then at the end of every module, we're going to have a quiz to check your understanding, see where you're at in regards to that module. Those are going to be given right here every Monday in class. So there won't be a quiz every Monday, but most Mondays there actually will be a quiz. It'll be a paper and pencil quiz, and you'll get the grades back usually within a week or so, or a few days. I know it's kind of new and actually a little bit different than how a lot of classes run themselves here at WashU. It is going to feel maybe a little odd at first, but once you go through this rhythm a couple of times, I think you'll sort of get used to it, the way that we do things here. And with that in mind, I actually want to switch over and talk about some of this stuff in a little bit more detail by going over to Canvas. So Canvas is really, I think, the most important part of this entire course in terms of finding where information is, finding where due dates are. If you ever have any questions about this course, your first stop should be Canvas. All of the material for the entire semester is actually already posted on here. So in a lot of cases, you theoretically could work ahead if you wanted to. I don't really necessarily have a problem with that. But understand that here in class, we are going to follow that very steady pace of one new topic per week, right? And so we can actually see that the first module right here, we're going to have our first, today is our first lecture. So I'll be introducing the topic here in just a little bit once we get through the syllabus. On Wednesday, we're going to ask you to go through Studio 0 and get your first in-class example, writing some code with your peers. At the end of every studio, the way you get credit for that, actually let me switch over to the syllabus and start talking about the different graded components. The way you get credit for studios is simply by showing up and participating. So you get credit for studios just by coming to class, just by showing up and actively participating. If we see you on the phone, on your phone the whole class, we may say, hey, you're not going to get credit for studio today, you got to participate. If we see you working on homework for a different class, right, we may say, hey, you got to work on the studio, or you're not going to get credit for being here today. You do not have to finish it. You don't have to finish the studio. You don't have to get it correct. That's not what we're looking for. We're looking for you to come in and give an honest effort for 80 minutes over the course of the studio. At the end of every studio, we're going to ask you some reflection questions, which again are not graded on correctness. They're simply questions for you to ask yourself. Which part of this concept is still tricky for you? Do you still not understand, right? A way for you to process, right, the information that you've learned and identify the areas that you may still need a little bit of extra help in, so that when you go home, you can work on those areas or come back to our office and ask more questions and get the help that you need for those areas. So to get the credit for studios, you just have to show up and make sure you fill in the reflection questions at the end of the studio after you participate for 80 minutes. The quizzes I already explained are going to be given here in class over the previous week's material. And then the exams, which I haven't talked about yet, the exams are in the evenings. And so I like to point this out actually on the calendar, make sure everybody knows on the very first day when the exams are going to be taking place, because these days are not going to move for any reason whatsoever. The exams are in the evenings, so please make sure you're aware of when the exam dates are. You can actually find the dates not just for the exams, but for the entire semester on the calendar page on Canvas. You won't see as much as I do. I actually see every single section. That's why it's showing up a whole bunch of times for me. But here's our first exam on September the 25th, and that is an evening exam from 6:30 to 8:30 p.m. There are 2 other evening exams on this calendar as well. So please, if you are planning to do any traveling or have any clubs or anything like that you're considering participating in, please take that into mind. I know some students like to take classes in the evenings. That is not, in my, in our position, an acceptable reason to miss an exam. So you are aware of these exams. We're asking you to form your schedule accordingly, right? The exams are in the course description. So we're asking you to form your schedule accordingly, knowing that you're going to have to take these 3 evening exams. And then as far as other information goes regarding exams, there's actually a 4th exam. There is a final exam, but we only count 3 exams towards your final grade. So actually for all 3 of these components, you have wiggle room. You can miss 2 studios, you can have 2 studio absences, and it won't affect your grade at all. So you get 2 misses if you get sick, you have to go home, whatever the case may be, right? You get 2 misses and it won't affect your grade. Same thing for the quizzes. You're allowed to miss 2 quizzes and it's not going to hurt your grade, right? So same reason as the studios, right? If you get sick or something, you can't come to class for whatever reason, stay home, get better. You're allowed to miss a couple quizzes before it hurts you. And then for the exams, you're allowed to drop 1 exam. So we're going to drop your lowest exam at the end of the semester. For a lot of students, what that means is they get good grades on exam 1, 2, and 3 and decide not to take the final exam. I'm totally fine with that. I don't have a problem with that whatsoever. If you've shown me that you understand the material on exam 1, 2, and 3, then you don't need to show me that you know it again on the final. You've already shown it to me. That's fine enough for me. If you get sick on an exam day, if you have some other kind of emergency on an exam day, then the final kind of serves as a makeup exam of sorts, right? You missed exam 2, but you can come take the final exam and that'll replace your exam 2 grade since you were sick. So that's kind of the policy here. Notice that instead of offering makeups, we offer drops. So if you ask me, can I make up a quiz? Can I make up a studio? Can I make up an exam? The answer more often than not is going to be no. But I do also want to say that while these policies will work well for the vast majority of you, there are situations that I can't predict, right? So if you find yourself in a situation where you're missing more than 2 studios or missing more than 2 quizzes or more than 1 exam, come talk to me. Let's talk. Let's try to find, figure out a path forward. Do what we can to make sure that you can still do well in this class. I never will give up on anyone. I will always try to find a path to completion if you come in and talk to me, right? You have to come in and tell me what's going on. I can't read your all situations, but if you come in and chat with me or Dr. Nuri, we'll try to help you find a path to complete the course. So Those are the three big graded items. I've been talking an awful lot. Are there any questions that I can answer about? I'm not done talking about syllabus stuff, but any questions I can answer right now? Yes.
You said that there was 4 total exams.
Correct.
I'm looking at the calendar. I'm only seeing 3.
Yeah, great. The final exam hasn't been scheduled yet, so that's done by the university. I told them I want a final exam. They know I want a final exam. They haven't told me where and when it's going to be yet. As soon as I get that info, I will let you know. It'll be during the final exam period. So, but I don't have it yet. I expect to have it soon. Yeah. Any other questions that I can answer? Yeah, in the back. Absolutely, yeah. If you take every single quiz, I'll drop your lowest 2 at the end of the semester. Yeah. Yep, absolutely. Any other questions that I can answer before we move on to the next thing? Okay, great. Let's talk about how to do well in this class, because I think that is probably one of the biggest questions that I get, and it's actually changed. The advice that I give to students has changed quite significantly in the last few years, and you can probably already sort of guess the reason why my advice to students about how to do well in this class has changed. It has to do with our good friend AI, right? Our good friend ChatGPT has really changed how we do business. I don't think just in this class, but in a lot of classes. I know a lot of you are first years, so you haven't necessarily been here a few years to see that shift, but I assure you it's happening. You're kind of getting a taste of it in the fact that we don't grade homeworks anymore. You might be thinking that's because we're seeing a lot of ChatGPT use on the homework assignments, and that's correct, but it's not so much the academic integrity that I'm concerned about. It's more the utility, both to you all and to me, of a particular assignment to gauge how well you're doing on a particular topic or a particular piece of information. So what was happening a lot is that students were getting 100s on the homeworks, presumably because they had a big push from ChatGPT, and thinking they were cruising along in the class, and then the exam comes along and bam, right? They just fall flat on their face because, I hate to break it to you, but using ChatGPT is not a good way to learn a skill. Learning requires effort, and when you think about what we're trying to learn in this class, we're trying to learn how to write code, right? I'm not going to deny that ChatGPT is great at writing code. ChatGPT makes writing code really easy, and that's the problem. Learning requires effort on your part, right? I know ChatGPT can code stuff really well. I don't need you to show that to me. I don't need you to prove that to me. I want you to prove to me what you can do. What code you can understand, what code you can write. When you show up to take the exams, I'm going to ask you to write code, and you're not going to have ChatGPT. You're not going to have anything other than a sheet of paper with some notes on it to help you out on the exams. So you're going to have to know how to write code. And you might be asking yourself, okay, well, if ChatGPT is so good at doing it, why do we need to learn how to do it then? Right? I think that's a very valid question, especially if you've been reading the news lately. I've seen some great headlines in the last few weeks, such as computer scientists graduating and going to work at Chipotle. That's not what I want to see. That's not what I want to hear. That's probably not what you all want to hear either if you're sitting in this room trying to learn computer science. But the market is pretty different than it was a few years ago. I think personally, and this is just one man's opinion, but the low-hanging fruit is gone, right? There is still a lot to do and a lot to learn in the tech industry. Tech is not going away. AI is exploding. AI is blowing up. There's plenty of work to be done, but it's not printing money like it used to be, like we used to tell people, even 5 years ago. There's not a lot of low-hanging fruit anymore, right? The bar to get into tech, I think, is higher than it used to be. That's not to try and discourage you. I'm just trying to keep things realistic. Why should you take this class? Why should you be in this class and learn these particular skills? A couple of different reasons. If you're interested in tech, right, this is the foundation. This is the building blocks. It's like saying, in my opinion, it's like saying you need to learn how to do arithmetic, addition, subtraction, and multiplication before you can do calculus. Well, of course you do, right? In this class, I'm teaching you the addition and subtraction of computer science so that you can go on and do the more complex kinds of things that AI and other sorts of tech requires these days. So you still have to know those building blocks. You still have to be able to have conversations about those with your peers and understand what's going on. I think the other thing to keep in mind, if you're not planning to go into tech, right, it's going to build your critical thinking skills. So it'll help you understand how to dissect problems in a more critical way. I think it's a very valuable skill, even if you don't end up writing code for a living. Knowing how to understand problems, dissect problems, and break them down is a very, very good skill that I think computer science is very good at helping people learn. If you're here to, try and get rich quick by making apps, sorry, that train has left the station. I think there's still money to be made in making apps, right? But if you're here to learn vibe coding, nope, not this class. We're here to actually learn how to do it. We're actually here to learn how to write code ourselves. You will see me use AI in this class a little bit, and I'll chat about AI quite a bit. But I won't be using it a whole lot. Almost all the code you see me write will be written by my very own hands, and that is my biggest advice to you. Get your hands on the keyboard as much as possible. Type code as much as possible. Practice code as much as possible. Every week before we come to class on Mondays, there is what's called, we call it prep work. So I'll show you the very first one. I'm actually going to take a look at it with you here in just a few moments once we get done talking about syllabus stuff. But here are what we call the Module 1 exercises. And if you click on this, it'll open up a link to a page that has a whole bunch of information about Java, about writing code. There are exercises in here where it's going to say, open up a text editor, a code editor, and do this exercise. Don't just sit there and read it, do it, right? Get your hands on the keyboard, do what the exercise is asking you to do. The best way to learn is by what's called active learning, by actually doing the things that you're trying to learn. If you let ChatGPT do the things for you, you're robbing yourself of that learning opportunity. So the more you practice, the better you're going to get at learning this stuff. My goal, I feel like, is to provide you as many opportunities to practice as possible. So I know you won't do it today because it's the first day of class, but the next time you come to class on Monday, which won't be next week because we have a holiday, but the week after that, I hope that you do the Module 2 exercises, take a look at them before coming to class. I hope you come with questions. I hope if you get stuck on one of the exercises, you come and you ask Dr. Nuri to do it for you in front of the class. We won't have the time to do every single exercise. There's simply not enough time. Sometimes I'll ask you questions. I'll ask you all review questions, try and get you to, get a feel for how well you understand the material. A lot of times I'll work through as many exercises as I can get to, but I like to let that be led by you all as much as possible. So please, ask questions, ask me to work through examples, and do the examples yourself. Don't just sit back and treat it like a movie. The best way to learn is by doing. So do as much as possible. Same with the homework assignments, right? I know I said I'm not going to grade them. I still hope you do them. I still hope it's good practice. You kind of have the benefit of not having to get everything exactly right. You know what I mean? So you can still get a lot out of the homework assignments without having to get a perfect score or whatever the case may be. So I think there are still a lot of advantages to doing that homework assignment. I still hope you consider taking the time to do that because that's the best way to learn. It's the best way to build those skills. If you come to me after the first exam and the second exam and say, hey, I thought I was doing well and then I tanked the exam, my very first question to you is going to be, how much do you practice? What are you doing to practice outside of class? Are you doing the exercises? Are you doing the homework assignments? How much are you getting your hands on your keyboard? That's going to be my first question every time. That's by far the best way to learn, better than listening to me or Dr. Nuri, better than anything, is to do it yourself. So please, 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 I don't know your opinions about ChatGPT, but please don't use it in this class. Right? Outside of maybe a few very narrow circumstances, which I may discuss from time to time, using ChatGPT on assignments or any of the practice exercises is literally robbing yourself and will, in my opinion, set you up to fail on the quizzes and the exams that are coming in the coming weeks. So that is my ChatGPT rant. That is my best advice to you on how to do well in this class. So yeah, you actually are allowed to use ChatGPT. Just to be 100% clear, ChatGPT is not banned. I'm not going to go check and turn people in for using ChatGPT. I don't have enough time in my day. I literally do not have enough time in my day to worry about stuff like that. What I do worry about is helping people who genuinely want to learn this stuff. So I will go through examples with you in my office. I will go through my whole lecture over again with you in my office, if that will help you learn. But if you come in and you try to show me some stuff from ChatGPT, I'm going to be like, hey, I don't want to talk to you about code ChatGPT wrote. I want to talk to you about code that you wrote. So keep that in mind when interacting with us and interacting with this class. Try to get as much of that practice in as possible. Outside of class, how can you get help if you have questions? So the TAs have office hours, which I believe the schedule is already posted. You can see the office hours link here. So the TA office hours are posted. Yeah, they won't start for a little bit, but they are going to be available every Monday, Tuesday, Wednesday. I am also available on Mondays and Wednesdays. I have open office hours from 10 a.m. to noon. And then on Tuesday and Thursday, I'm still available to meet, but only by appointment. You can use this link to schedule an appointment with me on Tuesdays and Thursdays. Dr. Nuri's going to get her office hours up soon as well. So there are lots of people available who want to help you, who want to answer your questions. And also, we're going to be using the discussions page on Canvas. So if you ever want to ask questions about an assignment or anything else, please use the discussions on Canvas. The TAs are all on Canvas, so they can see these messages and get back to you. I, of course, am on Canvas and can get back to you. And I will also be using Canvas for all course announcements. So please, check Canvas pretty regularly. Make sure you're staying on top of things. That's all my syllabus stuff, I think. Are there any questions that I can answer about syllabus stuff, course structure, anything along those lines before we switch and talk about some computer science? Yes?
So you suggest you do the modules before class?
Yes, the way that this class is intended to be taken is for you to review the exercises, what are called the exercises before coming to class on Monday. I actually believe I have those on the calendar. Let me pull up the calendar to show you what I mean by that. So there's no class next Monday because of the Labor Day holiday, but if we look at the following Monday, it'll say module 2 exercises. It says due at noon, but that's just to try and encourage you to do them before coming to class. They aren't graded, right? But the hope is that if you at least look at this stuff a little bit, we're not expecting you to understand it necessarily backwards and forwards. In fact, if you have questions, bring them. That's a great time to talk about the questions. But we definitely, we're not going to be able to cover every single exercise. So it's on you to make sure you understand this material. You are responsible, right? Ultimately, that's kind of what we're saying by not counting the homeworks and stuff anymore, is saying you are responsible for learning this stuff in whatever way is best for you. But I think practice is definitely the best in my personal opinion. So yeah, if you complete these exercises ahead of time, we'll just be able to have a bit more substantial conversation about the material than if I'm just up here telling you everything brand new for the first time, which is honestly kind of more boring for me, to be perfectly honest. I would much rather talk to you about stuff than just spew a bunch of lecture for 80 minutes. Yeah, I personally am going to ask you to do lots of exercises and coding problems when you come to class on Monday, so bring your laptops and be ready to think and do some practice right here in class too. As I said, more practice is better, so I'm going to make sure you get practice on Mondays as well. Any other questions? Yes?
So the module 1 exercises, we want them done before the section on Wednesday instead of before.
Yeah, so normally I'm about to jump into module 1 right now, but obviously I wasn't going to ask you to do them before class today. It's the first day of class. I'm not that mean, right? I'm not mean at all, I promise. Yeah, I'm asking you to, take a look at them. I mean, honestly, even by Wednesday would be good. I think actually by next Wednesday would be even acceptable, since that's when Studio 1 is going to be. For Studio, you kind of reminded me though, thanks. For Studio this week, one of the things that we're going to be doing, one of the primary things that we're going to be doing is the software installation and setup. But you are welcome to do this whenever you want. So if you want to try this before class, I would encourage you to do so. It's actually not that difficult. It got even easier this year than it has been in past semesters. So, take a stab at this, and if you get stuck or you come to something, you're like, I have no idea what's going on, okay, don't worry about it. Bring your computer to class on Wednesday, and the TAs or myself or Dr. Nuri will be able to help, figure out whatever issues you run into. But all of the exercises, everything that you need to get started coding is already on here. All the instructions are on here. So if you want to start doing stuff right now, you have everything you need to go ahead and get started. The software installation and setup is the first place to go, and then start diving into some Module 1 exercises would be the next place to go after that. So, but we're going to walk through, we're going to make sure everybody does that on Wednesday. You don't need to have that done right now. That's something we're going to make sure everybody gets done on Wednesday in the labs. Any other questions before I switch gears a little bit, move on to some computer science stuff? Any other questions? Okay, great. Fantastic. So then with the, we've only used about half the class time, which is great. For the remaining half of the class time, I'm going to go ahead and dive right in and start talking about some computer science stuff. I don't expect you to have everything loaded today. So this is one of the rare occasions where I'm going to say, maybe just kind of sit back and relax and don't try to follow along with me necessarily today. Normally I would prefer that you have all this stuff loaded up and are able to follow along with me better, but it's the first day of class, so that's not a reasonable expectation. So I am going to do more of a kind of traditional me talking about stuff today, but in the future it'll be a lot more interactive, I'm hoping. So be prepared for that in future weeks. What I'm going to do for the rest of the time is actually start in on the Module 1 exercises. So I'm asking you to look at these yourself outside of class, and I still hope that you do, because as I've already said, I'm not going to be able to do all of them. I've only got 40 minutes. I'm not going to be able to get through all of them today, but I do want to get through as many as I can, give you a little bit of a taste of what this class is like and the kind of work we're going to be doing this semester in this class. So I'm going to switch over to a different program. This is called Visual Studio Code, and actually, let me see if I can make the text a little bit bigger so that you all can read it a little bit better. Should have thought about that before class, but I didn't think about it until just now. All right. Just a second here. Where is the font? All right, bump this up a little bit. Oh, that's not what I meant to do. That work? Oh, yes, it did. Perfect. Wonderful, wonderful, wonderful. All right, so this is something called VS Code. This is the program that you all are going to be asked to download and install on your own personal computers in the coming days. That on the software installation and setup page. You will absolutely need to have this done by the end of class on Wednesday, but as I said, we'll be in class on Wednesday to help you with this process. I'm not going to talk a lot about the installation stuff right now because we have time for that on Wednesday. So right now I'm going to focus more on just diving in and talking about code and what code is and what we're going to be doing here in this class this semester, starting with the very first example that we see. So I'm in a folder called Why Java, and the examples are all numbered, the exercises are all numbered. So I'm looking at this first one that's a hello example. This is, at least right now, the simplest Java program that we can possibly write. But let's back up a second and talk about some of those things. Starting with Java. Java is a programming language, so it's not the only programming language. There are other programming languages that maybe you have heard of, like Python or C++ or R or things like that. There's tons, hundreds, thousands of programming languages probably, right? We, in this class, I'm not actually too concerned with the language so much as the concepts, the programming concepts that I'm going to be showing to you. The language is merely a tool, right, to show you how we can accomplish things on the computer. So to try and illustrate what I mean by that, consider that if I wanted to explain a set of instructions to someone on how to do something, right, for example, making a peanut butter and jelly sandwich. Right? First, I would have to get the bread out, and I have to take out 2 slices of bread, and then I have to get the whole deal. I was explaining that to you in English. I could also explain to you how to make a peanut butter and jelly sandwich in Spanish or Chinese, right? Or any human language that I can think of. Does the actual act of making a peanut butter and jelly sandwich change regardless of what language you're told? It doesn't, right? The actual steps that you take, the actual actions that get performed are the same regardless of what language you're being given the instructions in. And the same thing is very true for computers, and something that's very, very important to understand, right? We are interested in solving problems. Language is one of the tools that we use to solve these problems, specifically the Java language, but a lot of what you're being taught in this class also applies to Python, also applies to C++, and all of, maybe not all of the other languages, there are some pretty weird ones out there, but the concepts that you learn in this class will translate very well even if Java is not what you ultimately end up using in whatever path you end up going down in your computer science career. So don't get too hung up on the Java side of things and think more about these programs as a series of instructions that we're giving to the computer. We're telling the computer what to do. And so in this particular example, we're creating a Java program. So a program is a cohesive unit, right? One series of instructions that does a particular task. And the task that we are accomplishing in this very simple, bare bones, as easy as it gets program, this is called a Hello World program. It's oftentimes the first step when you learn how to code in a different language. You simply make the computer say hi, make the computer say hello. And so I'm actually going to sort of skip over some parts of these and treat them maybe a little bit as like magic words, hocus pocus, until we get to later on in the semester. I'm actually going to kind of not talk about this so much and maybe not even really talk about these words so much, but I do want you to notice that they're here and they are necessary. I'm not going to tell you why today because that's a few weeks down the road, but we will get there. I promise you, once we get to Module 7, we'll come back and talk about what this means in a whole lot more detail. What I'm interested in today is this part right here. So this line, these are the magic words in Java. It might be different in other languages, but in Java, these are the magic words to say that the program starts here. This is the beginning of my program. I'm about to give you some instructions. I'm about to tell you some things to do. And this is one such instruction that says print. I see the word print in there. I see some other stuff too, but honestly, the one that matters most to us is print. And then inside of here, it says what we should print. And so if we run this program, which we can do in a few different ways, but you can see the word run is right here, or I can actually right click and say run Java right here. We tell it to run and down there at the bottom, it happily prints out the message that is told to it. And so this is, as I said, the simplest Java program. We're only going to get more complex, more complicated from here, but there's already stuff we can do. I want you to get used to playing around with things, editing things, changing things, and seeing what happens. I think that is really one of the best ways to practice, one of the best ways to learn. So you can see this exercise says, after you run it, modify it to print your name. All right, so I can make it print out my name by, instead of saying hi there, just double clicking that and typing my own name in there instead. Or if I want to just make it say hi to someone else, like my daughter, I could type her name in there, right? And then whenever I want to see that change, notice that it doesn't, this is still here, right? I didn't change what I've already done. I actually have to run this program again in order to see the changes that I've made. So go ahead and click the run button a second time, and now we see that when the program runs, instead of saying the past message, it says the new message that I've typed, right? We've successfully modified a program. That's great. That's coding. Coding is all about taking stuff, a lot of times stuff that already exists, and changing it to suit our needs, to solve the problem that we want to solve. I would actually argue that more programming is about that than it is about coming up with stuff from scratch, right? It's a lot more about taking ideas that have already kind of been thought about and thinking about how to repurpose them or reuse them for our own needs. So let's move on and take a look at some perhaps more complicated examples. I'm actually, as promised, I'm going to skip example 2. I would love for you to take a look at it and try it out and get some practice yourself. But I'm going to go ahead and skip down here to example number 3. It's a very simple, similar kind of program, right? But if you look at it, I now see I've got 3 instructions for the program to do instead of just 1. And so it's going to start at the top and work its way down, just like reading a book, right? One line after the other. So it might look like it's going to do pretty much the same thing as before. I see it says hi there, right? But let's go ahead and run this and see if we can't figure out what actually happens. And it's close, but it looks a little weird. Looks a little different to have that exclamation point on the next line like that. Does anybody have any ideas as to why that may have happened, or what the issue is with this particular program? How could we fix this? You can see that's what the exercise is. How can we fix this so that the exclamation point prints on the proper line? Does anybody have any ideas on how to help me out? Yeah, right up here. Okay, so notice that actually there are 2 different commands that are happening here. I didn't mention that. I kind of glossed over it, right? But as was pointed out, there's one called println and there's one called print. And you might be wondering, okay, well, what's the difference between the 2? You can actually find out by hovering over it. VS Code will happily give me a description, although as new programmers, sometimes these descriptions can seem a little confusing, right? There's words in there that maybe you haven't seen used in that particular way before. I get that. But so experimentation is also, I think, a great way of seeing what's going on. The suggestion, I think, was, and I might be wrong about what I heard, but the suggestion was maybe use println here. Let's try it. Let's just try it out and see what happens. And actually, I changed this to say println, and it doesn't actually seem to have changed anything. I think we're close. Let's try and think a minute. The ln's not, it means something. It's saying print line. So this is almost, an artifact of the old typewriter days, right? This is saying print out this stuff. Oops, I didn't mean to do that. Print out this stuff and then move down to the next line, like pushing the typewriter back over, right? So you can start on the next line. Whereas if I just say print by itself, that means print out this thing and stay on the current line so that whatever gets printed out next remains on that same line where I currently am. So I think the actual way to fix this would be to take the ln off of the middle one. Let's try that and see. Try and run this again and see if that's gotten us closer to where we're going. Yeah, there we go. Now it all appears on one line. Actually, could I change this to ln? I already did that before. What's going to change? Nothing. Nothing. Good. Yeah. 2 different ways of saying the same thing on the computer. I promise you that is not going to be the last time that happens in this class. There are always probably going to be multiple different paths, multiple different ways that you can say the instructions to get you to the same place. That is, I would argue, a very good thing, right? It gives us some flexibility with how we write our programs, how we write our code. But yeah, I think the big takeaway here that I want you to think of is that computers are very, 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 very literal, very particular, very strict. If I write it, that's what it's going to do. It can't read my mind and say, oh, the exclamation point should be up here. It doesn't know that. It's going to do exactly what I tell it to do. So if I say to put a line in here, it's going to do that. It doesn't know English grammar or anything like that. Did I see a question right here? Yes. So this is actually just something that Visual Studio Code is trying to tell me to help me out. This is actually, there's a way to turn this off. I don't actually remember off the top of my head how to turn this off. But for our purposes, you can actually ignore the S or the X. What matters to us is what is inside of the quotation marks. Yeah, good question though. Thanks for bringing that up. I appreciate it. Are there any other questions that I can address before moving on? Yes? That's correct, yeah. So the question was about how to print things in Python versus Java. I mean, it doesn't surprise me to hear that you've had some Python experience. I'm sure you're probably not the only person who does. This is the first example of many where I can show you that Java can do exactly the same things that Python can do, but it's going to look a little bit different. In the computing world, we call those differences syntax, right? And it's exactly what I was trying to describe earlier. It's the difference between saying, you know, home in English versus casa in Spanish, right? They both mean the same thing, but they look a little different depending on the language that you use. Yes?
So my question is, like, since Python is much easier, what's the point of using Java? Like, what's the point of like adding
You say Python is much easier. That sounds very subjective to me.
Yeah, I mean, like, just the one that we were talking about, like print for print, you only need print and parentheses, and for Python, Java, you use system out.
So I'll try to answer your question, I think maybe in a slightly different way. I would suggest to you that languages are a tool, and like all tools, some of them are better suited for certain problems, and other of them are suited better for other problems. So Python is most often used in, you'll find Python a lot more in the research area, in the research sphere. You'll find Java a lot more in enterprise businesses, big companies. The big reason why is Java is very famously known for being object-oriented. So that is, in fact, kind of the grand finale of this class. The last few weeks are going to be spent talking about this idea of it being object-oriented. It's a big deal. And object-oriented programming is still the most popular way of programming. Python can do object-oriented programming, but is considered to be not as good at it as Java or other languages are. So I'm not going to deny that Python has its uses. I don't think it's necessarily easier or better. I think it's just a different tool to be used in different situations than Java. Yeah. As to why we use Java, I mean, this class very much follows the AP spec. So we do things exactly the way AP does, and they're still using Java, so we're still using Java. It's really as simple as that. But I've used Java. I learned Java as my first programming language. This is my first programming language. I started learning how to code formally when I was an undergrad student back in the early 2000s, and I still remember the very first code that I wrote in Java was this: public static void main string args, right? So in some sense, the fact that Java's been around for a long time, has a well-established code base, makes it suitable for entry-level programming. Python does have its advantages. I love Python. But if object-oriented programming is your goal, I'd take Java any day. Yeah, still. And if you look at actually even programming language popularities, I think Python is the most popular language in the world, but number 2, this one. So it's not like we're choosing a nobody language that nobody uses. It's very much still very popular, very much in use, and it's not going away anytime soon. Yes?
I know that in Python there's like different libraries that you can import to get like specialized functions. I was wondering if there's anything similar to that.
Definitely, yeah. You can definitely import stuff in Java too. We'll talk about that maybe a little bit later on today. We're taking some baby steps right now though. That's a bit more advanced than where we're currently at. Thanks for all the great questions. I am going to move on to my next exercise. Everything we've been doing up until now has involved text. So yes, text is important, but it's not the only thing that we can do on the computer. Computers are actually very good at doing math. That's one of the great things about computers in my opinion. I like math, but I don't want to sit down and have to crunch all the complicated numbers, right? I want the computer to do that for me. So it's important to understand how to talk to the computer in terms of arithmetic as well. And here you go. You might see that, okay, we have a print statement. But this time, I'm not printing out hello. I'm printing out some numbers. And actually, a little bit more complicated than that, I'm printing out an arithmetic operation, right? And if I run this code, we'll see that it's not actually gonna print out 570 times 23. It's gonna print out the result of that computation. Excuse me. Thank you. So the computer is going to go ahead and do this. Right? The computer is going to go ahead and do this math. Same for this. It went ahead and computed this decimal value and printed it out. It didn't print out the equation. It printed out the results of that computation. Right? So this is all very, very useful. The computer very naturally set up to do math and run math kinds of things and will easily do so. But you have to be careful, right? You have to be careful about what you're doing and how you're talking to the computer. What's the big difference between how I use the print print line here versus how I've been using the print line here, do you notice something that is present or not present in one of these examples? Yeah. Quotation marks, right? So quotation marks were in all of the first few examples that I showed you. And that's because these are examples of text. Actually, in computer science speak, we would call these strings, which I know might sound a little strange. Why are we using the word string to talk about text? There's a reason. It's because this is considered a string of characters, a string of letters. That's where the name comes from, right? But in computer science speak, anytime you see text, we're going to call it a string. Whereas over here, this clearly isn't text. These are numbers. And actually, more specifically, there's more than one kind of number that we care about in computer science as well. So this is an integer, or an int. It's a whole number, right? Whereas this, we actually call something else. We call it a double, which might sound like an even sillier name than string is for text, right? There's a reason that we call it double as well that makes even less sense than the description for string does for your all purposes. It stands for double precision, which basically just means it has to do with how many places after a decimal, or how big of a decimal value can be represented by this particular value. But for our purposes, that doesn't really matter. For our purposes, what matters is that ints don't have decimal values, they're whole numbers. And anything that does have a decimal value, we call a double. Why make that distinction? That seems a little arbitrary, right? It seems a little perhaps unnecessary to even make that distinction. Does anybody have any idea as to why that might actually matter? Yeah. So yes, that's actually absolutely correct. These pieces of data take up space. Where do they take up space? They take up space in memory on your computer. Integers can be represented in 4 bytes. You've probably heard that term before, right? As a unit of space on a computer. Whereas doubles typically take up quite a bit more than that. They take up 32 or even 64 bytes, depending on the situation. And it might also, stand to reason that these take a little bit more work to compute, right? The decimal makes computation a little bit more complicated than it does if you're not worried about decimals and you just have whole numbers, right? So for that reason, we actually treat these separately. And it has a big effect. That's actually probably the biggest takeaway, I would say, from the first week's module of material. Every piece of data that we manipulate, that we work with on the computer, has what's called a data type. So I've actually introduced to you 3 out of the 4 data types already that you'll be exposed to in this first module, which are string, which we use for text, ints, which we use for whole numbers, and doubles, which we use for decimal values. I'll get to the 4th one a little bit later if we have time, but just to kind of illustrate why the data type matters so much, let's try a little experiment. And we saw quotes used a lot in the prior examples, but we didn't use them here. Well, what if we did? What if I did try to use the quotes here? How does that change, what actually happens? Well, we can try it. We can put quotes around that first value and run it again, and we'll see that this time it actually doesn't compute the answer, right? Why not? Well, we aren't treating these as integers anymore. We aren't treating these as numeric values anymore. We are treating these as text, as a string. So it's not going to do arithmetic with text kinds of things. That doesn't even make sense. Hello times 3 is equal to what? I don't know. It doesn't make sense, right? So the way that the computer interprets the values, the data, depends upon that data type. And as programmers, that means it's important for us to understand the different data types and how they apply to data within our program. So yeah. Any questions before I move on to the next example? All right, great. Let's keep chugging along, see how many more we can get through. Oh yeah, I already did this one, sorry. So I'm going to skip that one and go to number 7. So you're going to make mistakes. That is a fact. If you come into this class, or any part of this class, expecting to type the correct code the first time, oh boy, do I have news for you. It doesn't work that way. I have been coding for a long time, 20 years about. I do not expect to get the code right the first time. And I've been doing it for a long time. If I write a piece of code and it works the first time, I am suspicious. I am like, what is going on here? There's always a problem. There's always a mistake. We're humans, right? Humans make mistakes. I would argue that it is more important for you to understand the various types of mistakes that can occur and how to fix them than it is for you to be able to write code from scratch on a blank screen, right? The amount of time that I spend finding mistakes, fixing mistakes, right, understanding the mistakes and the challenges is far greater than the amount of time that I'm actually writing new code from scratch. And it's not even close, right? A lot of coding is not about just magically dreaming up the next big program and spitting it all out on the screen. That's not what it's like. A lot of it is finding where the problems are and fixing the problems. So with that in mind, I want to introduce you to the first category of problem that you're likely to run into, which is also the easiest, fortunately, for most people to kind of figure out, which are syntax errors. So syntax usually has to do with things like punctuation and stuff. We have syntax in English as well, where the commas go and periods and things like that. So, you know, computers have the same thing. You've probably already noticed some parts of it. In this very simple example, you can see that, okay, I have the first quote here, but I'm missing the second quote. And it's telling me that string literal is not properly closed by a double quote, which is a very, you know, wordy way of saying what I just said. I forgot the second quote, right? The good news is that, yes, syntax errors will be underlined in red, just like if you misspell a word in that paper that you're writing. And they will usually give you some kind of information. Now, whether you understand it or not, that's, you know, kind of what we're here for, to help you understand these things. Look it up. Paste it into Google. Paste it into whatever. I do that all the time. If I see a mistake and I don't know what the heck the computer's telling me, I'll just copy it and paste it right into Google and see if I can get more information about it. Don't be afraid to use other resources. That's also a part of programming. Understanding that you can't possibly know everything. You can't possibly be prepared for every situation that you're going to encounter. But you can be prepared to look things up when you need to and seek out that important information when you need to solve that problem. In this particular case, right, we can see that once we put the quote in, everything is happy and that red line goes away. So syntax errors, you won't even be able to run this code until you fix. That's what it means to be a syntax error. So in these examples that are labeled as errors, right, it's always because something is missing. In this particular example, we have a parentheses missing, right? But as soon as we insert it, we're now able to make this happy, and we can run this code now. This one, I believe, has a twofer. There's two things wrong with it. Might seem nitpicky, but the semicolon is like the period at the end of a sentence for the computer. So every single line of code is going to have that semicolon. And then this other one might seem super nitpicky, but it's something that you're going to have to get used to. This S needs to be capitalized. So case matters. The capitalization matters very much. If you're sloppy with it and you don't pay attention to little details like that, you're going to have a bad time. It's not going to be a fun coding experience for you. Computers are not forgiving about this stuff. They aren't going to let little mistakes like that slide. They're going to expect you to fix them all before they will do anything for you. Yes, question? Not every time you have an error, so that's a great question. It will not be able to show you every error that you have. This is a specific category of error known as syntax errors. So everything is based on, so the main examples are when pieces of punctuation are missing, right? I forgot the semicolon, I forgot a parenthesis, I forgot a quote, I forgot capitalization, things like that. There are other kinds of errors that will not be caught ahead of time, and you're not going to find out until you run your program, and then, you know, maybe it crashes. That definitely happens. That's a different kind of error. Or maybe it doesn't crash, but it gives you the wrong answer, right? You expected it to say this thing, but it said something totally different. That is another kind of error. Again, the computer can't guess your intent. It's not going to say, oh, you made this program to do differentials, so I'll just magically do them properly. No, if you don't give it the instructions properly, it's going to do the incorrect thing, just like you told it to. So those mistakes are actually a lot harder to find and fix than these kinds of syntax errors. The syntax errors are usually the easy ones to fix, but when we make mistakes in logic, that's when it can be kind of confusing or surprising to get the results and take a little more work to figure out. Another question?
Is that like one case where ChatGPT may be like acceptable to use as kind of like a debugger if like you look over it and we just can't really figure out what's wrong?
Okay, yeah, I'm glad you brought up that question. The question was, is that would be a situation where ChatGPT would be okay to use to figure out where problems are? That is something that people use ChatGPT for. And to be clear, your question of whether it's acceptable or not, I mean, I'm not here to judge, right? Like, you all are adults in this room. You all need to make your own decisions on how you're best gonna navigate this class. I'm trying to tell you that practicing and doing the homework is it. I don't think you should be considering using ChatGPT at all unless it is specifically mentioned by me or the other instructor that it could be a possibly good thing to use. I'm going to teach you how to solve those kinds of problems using non-ChatGPT-like tools, which is all then to say that in the future, if you take upper-level coding classes or are paid to be a programmer, yeah, absolutely, I would use ChatGPT to help me solve those problems. But when I'm trying to learn how to do it, no, I don't think that's a good idea. I think it's too dangerous, personally. Yep. But that's up for you all to decide and hopefully not learn the hard way. But we'll see. We'll see how the semester goes. Any other questions? Yes?
So is it like required to put like a spacing like that?
Which part in particular?
The semicolon and also like the sentence.
So the question was about the spacing. I mean, the spacing, so actually spacing is a little bit flexible. There are times when it is flexible and times when it is not flexible. So for example, I mean, I think I could do something silly like this, and the computer's not complaining, right? Like, the semicolon's technically there. This is a mean thing to do, because anybody else who looks at this and be like, where's the semicolon, right? So kind of a mean little coder prank to do to somebody, but it still works. Doesn't stop the code from working. I wouldn't recommend it, right? So, other cases where the spacing might make a difference, I think there's a lot of places where it would be fairly flexible, right? Like, I can do this all I want. But if I start putting spaces in here, well, that's actually changing the text that's getting printed out. So that does make a difference. That actually would change things by putting these spaces in here. I would see that get reflected in the output. So spacing is one of those things where it doesn't always matter. Sometimes it does. Even when it doesn't matter, you're going to see me stick to pretty consistent spacing, if for no other reason than it keeps things organized. So organization's a big part of code as well, especially if you're trying to understand what's going on. It's a lot easier to understand the way I had it before than, if I tried to show you an example that looks like this with a whole bunch of weird spacing. So I know this is an extreme case, but yeah, great question. Cool. Let's talk about variables. So variables are sort of a natural extension of the idea that everything has a data type associated with it. What a variable does is it allows us to remember a piece of information. So we are applying a label to a piece of information so that we can recall that piece of information later. So in every example that I showed you so far, right, for example, this one here was simply printing out the result of the computation, but there was no way for me to recall that result later on, right? It just printed it out and then poof, that value is it's done. It's gone, it's served its purpose, and I can't do anything else with it. If I actually want to remember something, then I need to create what's called a variable to apply a label to a piece of information, and it actually follows two parts. So there is what's known as the declaration. The declaration is always a type followed by a name. So the type in this case is an int, short for integer, and the name is going to be score. And then the second part of creating a variable involves this is called a variable assignment. So I think it's very important to understand that the way to read this is to actually from right to left. So the equal sign has kind of a loaded meaning, especially since I'm assuming a lot of you have taken some math classes in the past, right? This is not equality. in the sense that the left thing is equal to the right thing. This is a variable assignment, meaning I'm going to take the value on the right-hand side and I'm going to apply this label to it. I'm going to have a label called score. And if I say the word score, then I expect to get that value back. In practice, we actually don't separate these two things all that often. You can separate them, but in practice, if I were actually doing this, I would do it all in one line, like this. And we actually see this variable is done in a similar way. So if I want to create a variable in Java, first thing I need to decide on is, what is the type? Is it an int? Is it a double? Is it a string? So I'm going to write that down first. Then I'm going to give it a name. And I know this is probably somewhat obvious advice, but it should be a name that is descriptive and will help you remember what that value represents. It's, you know, I've been doing this class for a long time. I get students who come into my office every semester to ask questions about homework, and they call their variables poop and fart and all kinds of other fun stuff, right? But that's not going to help you understand what's going on. It doesn't help me understand what's going on. We'll get a good laugh out of it, but it doesn't help us understand what's going on, right? So as funny as that is, resist the urge to make funny jokes in your code. The goal here is understanding, which means we should choose descriptive names as much as we possibly can. And then from here, you can see that anywhere that I can use, you know, an integer, I can now refer to this variable name. And so when I print out this variable, it's not going to print out the word score. It's going to print out the value. Oops. It's going to print out the value that's associated with that variable. So it's going to print out 4. And the same thing for this double down here. It's going to print out not the word price, but the value that's associated with that word, the value that is been assigned to that variable. And that leads me to the fourth and final data type that I want to show you today, which is called a Boolean. Another weird sounding word that you probably haven't heard very much, if at all, before today. This one's named after a person. Boole is his name. He was a mathematician. So very famous mathematician. Go Wikipedia him later. He's a pretty cool guy, in my opinion. Boolean values are pretty simple, and that there's only 2 possible values that they can have. They can be true or they can be false. Why do we care about true and false things? How does that make sense to us? Think about what are computers thinking like? Yeah. Binary, yeah. So ones and zeros. Under the hood, right? Everything we do on the computer ultimately ends up being ones and zeros. Everything. Even this program, even this code that we're writing, when you click the run button, the computer there's a lot of stuff that happens, actually. A lot of stuff that happens. And if you're interested in more about that, I actually teach a compilers class that I'd be happy to chat with you about sometime, but this isn't that class. So I'll give you the short version. It takes all of the code that you've written and turns it into ones and zeros, because the computer cannot actually run this directly. This is to make our lives easier. These languages exist to bridge the gap between the ones and zeros and the way that humans like to talk, communicate, which is language. So Java is sort of somewhere in between the ones and zeros and the human languages. And so when you click that button, it turns into ones and zeros. And having Booleans is a great way to represent binary types of decisions, which it turns out pop up all the time when we're writing code. So this is by far one of the most common types of data types we're going to be using in this class this semester. So it's kind of nice that it's sort of simple. It only has 2 values, true and false. There are other things you can do with it we'll talk about in the future. Did I have a question over here? Boolean means it's going to be a true or false value. A double is any number that has a decimal value after it. So the number of decimals doesn't matter. This is still a double. And actually, even if you do something like this, 23.0, while technically could be considered an int, right? The way I have written it, since it contains a decimal point, it is a double. So just like we kind of saw for strings, right? Having the quotes is your way of saying, hey, this is a string. If you see a decimal point, I want your brain to think, oh, this is a double. This is a double. It's not an int, it's definitely a double. Even if it's 0.0, it's still a double, right? That decimal point is what makes it that particular data type. Great questions. Any other questions I can answer? Yeah?
I'm like a little confused. So, You capitalized the S there because you didn't do it from the T or the D. Is that like supposed to be like that?
Yes, actually. So this S is capitalized, that's correct. That's because of, this is referring to something called system, which is Java's way of representing your computer, basically. These data types, int, double, and boolean, yes, they are lowercase. That is also intentional. That is how Java expects it to happen. That being said, this is an interesting case where if I do capitalize this, it'll actually still work. However, this is a little bit different than using the lowercase version. The reasoning behind it, I think, is outside of the scope of where we're at right now. Maybe later on in the semester we could have a more interesting conversation about that right now. But you'll see a lot of stuff will in fact be lowercase. Not everything is capitalized. It's not like capitalizing the first letter of a sentence. That is not the rule, right? It has more to do with what we're talking about. If I'm talking about the data type like this, it's always lowercase. If I'm talking about system, that's always capitalized, regardless of where it appears in my code. Does that kind of help? Yeah, cool. And some of these things I wouldn't expect you to know. Some of these things it took me, sort of years to internalize myself, right? There's a lot going on. I'm throwing a lot of info at you, so I appreciate you asking questions, trying to figure out what's going on. One final example, because I know we only have a few minutes left, but I really want to illustrate this point where the type matters so much. The data types matter so much. Because here in this example, we have right here a plus sign, and you all know what plus signs are for, right? It's addition, 2 + 2 = 4, stuff like that. But wait a second, this is not a number. This is a number. I see score is being initialized to have a value of 0, right? So score is a number. I can see the data type is an int. I can add ints, right? That makes sense. But what does it mean for a string and an int to be added together? That doesn't make sense to me. How does that work? Well, this actually is an addition. This is not addition. If this were an int or another number, like the number 7, it would be addition. This would be the regular old addition, like we all know and love. But since this is a string, this operation becomes something totally different. It's called concatenation, which is a really long, complicated sounding word for just taking two values and sticking them together, just combining them into one value. So I have a string concatenated with an int. The result, the output of that is going to be a string that contains whatever this value is on the end of this line. And you can verify that by just running this, right? So we now have a way of combining things of two different types together, but the data types really matter a lot. Just by making this a string instead of some other numeric value changes what this operation is. And this isn't the only example of that you'll run into as we go through the semester. It's always important to remember what the data types are and how that's going to affect the code that you're writing. So I only have a couple minutes left. So let me please just go ahead and wrap up by saying, between now and Wednesday, I would like for you to at least attempt the software installation. If it doesn't work, that's okay. Bring it to class on Wednesday. We'll make sure everybody gets squared away. And then please take a look at the Module 1 exercises. That would be the next thing to take a look at. Thanks, everyone. Hope you have a good rest of your first day. I'll see you in the labs on Wednesday.